So the solution to the test: when Brian O'Driscoll runs north at 1 meters per second, the wind appears to come from the southwest. So here's a little diagram. To come from the southwest, it's coming from this direction, so it's ending up in this sector, positive, positive. And we know southwest creates a 45-degree angle. So in here we can say x is going to be equal to y. So let's write out our velocities. The velocity of Brian is equal to 0y plus 1 in the j direction. The velocity of the wind relative to Brian is equal to, because of the 45-degree angle, I'm going to call both of these variables x, so xi plus xj. So the velocity of the wind, in this case, is going to be the other two added together, because of the velocity of the wind relative to the buoy being equal to the velocity of the wind minus the velocity of the buoy. So bring the buoy back to the left and we'll get the two added together. So x plus 0, x in the I direction, plus x plus 1 in the j direction. That's scenario 1. Scenario 2, Brian has decided to cycle. Now he's going 5 meters a second, so 0y plus 5j. And you know, when you're cycling, the wind feels different when you're cycling. The wind relative to Brian now appears to come from the northwest, so a completely different direction. It's coming from the northwest. It's going down here again 45. In this case, it's positive, negative, so x is equal to minus y down here. So the velocity of the wind relative to Brian is equal to xi minus y in the j direction. So the velocity of the wind is the two added together, x in the I direction plus 5 minus y in the j direction. So I can equate my i's are the same, we just have x here, so I've got to solve for x to get my I. So here we have x plus 1 has to be equal to, so I put in a y there, I should have 5 minus x, just change it around now, 5 minus x, so 5 minus x is equal to x plus 1, so 2x is equal to 4, so x is equal to 2. So the velocity of the wind is equal to 2i, and 5 minus x will be plus 3j, or 2 plus 1 is also plus 3j. So the velocity of the wind, 2i plus 3j in question 1, so you should have circled or ticked D. Number 2 here, when Rory Best runs at 2 meters per second, so the velocity of Rory is equal to 0y plus 2j. The velocity of the wind, same question again, just different variables, appears to come from the southwest. X is equal to y. So the velocity of the wind relative to Rory is equal to xi plus xj. You could say yi plus yj if you wanted, it just depends what you want to use. The velocity of the wind, the two added, x in the I direction plus x plus 2 in the j direction. That's scenario 1. When he cycles at 7 meters a second, his velocity is 0y plus 7j. The wind relative to Rory appears to come from the northwest again, so we can say positive, negative, so xi minus xj. So the velocity of the wind is equal to x in the I direction plus 7 minus x in the j direction. So we can say that 7 minus x is equal to x plus 2. 2x is equal to 5. X is equal to 2.5. So the velocity of the wind is going to be x in the I direction, 2.5 in the I direction. and x plus 2 plus 4.5 in the j direction for question 2, which was B. Question 3, two straight roads intersect at O at an angle 60 to one another, and A is here and it's traveling towards O, and B is here and it's traveling away from O, and we're given this distance of 200 and 450 for their distances away from O, and we're asked to calculate the velocity of A relative to B. So let's get the velocity of A. It's going down in this direction here, so it's going down into a negative sector, so it's going to be minus, and we have its speed of 16 by the cos of the angle, which is 60 in the I direction, minus 16 by the sine of the angle in the j direction. And that's going to give cos of 60 is a half minus 8i, and root 3 over 2 minus 8 root 3 over 2. Now I've gotten rid of the 2, minus 16 minus 8 root 3 in the j direction. The velocity of B, well, B is just moving in the positive I direction, so 20 in the I direction. So we're looking for the velocity of A relative to B, so A minus B. So minus 8 minus 20, minus 28 in the I direction, and minus 8 root 3, and there's nothing here, 0 in the j direction. So just minus 8 root 3 in the j direction, minus 8 root 3 in the j direction. Is that one of our options? Option D, you can see it was correct here. Now, if at a given instant, this is when they're 450 away, A is 450 away up here, and B is 200 away here, calculate the time interval in the until the cars are nearest each other. Well, we'd be looking at shortest distance here. So my shortest distance here doesn't want to stay on the video for me. Trying to use new slides. So let's see, does this work? My shortest distance x here. So we have to find out how long it takes A to get from here to here. Most of these questions we get one of the cars to the junction, so let's get A to the junction. It might make this question easier for us. So A is 450 away from the junction at 16 meters per second. That's going to be 225 over 8, which doesn't simplify any further. So that's going to be 28.125 seconds for A to get to the junction. So what have we got going on now? We have A, we have B somewhere along there. We have the velocity of A relative to B. I'll just do a dotted line here for my x-axis. So we have the velocity of A relative to B. We have A is here, B is somewhere along here. Okay, where is B along here? He has traveled for 28.125 seconds and his speed is 20. So that's 20, 28, 560, and an 8 of 20. And that's the danger of using slides. 28.125 by 20 is where I was at. 560 and an 8 of 20, 562.5 meters. And he was 200 meters. So add 200. We've got 762.5 for B. So this diagram that disappeared. We have my angle, I have my velocity of A relative to B. I have A, I have B, somewhere along there, I'm X my shortest distance, and now I have this distance here of 762.5. So if I can get theta from, we had the velocity of A relative to B from earlier. Velocity of A relative to B was minus 28 in the I direction, minus 28 in the I direction, minus 8 root 3 in the J direction. So the tan of theta is equal to 8 root 3 over 28. And that will give me theta to be. Oh, don't disappear on me. Oh, there it is. Getting used to this. Theta to be 8 root 3 over 28. Inverse tan of that. So inverse tan of 26.33. And I can use that now to get my shortest distance. Actually, this is the distance I'm looking for along here. So this is adjacent to, here's my right angle. So this is adjacent to the angle. So I can do the cos of theta is equal to, sorry, my adjacent is the side I have here. I'm looking for this side along here. So the cos of theta is equal to my adjacent side is the one I'm looking for. I'll just call it A for now, A over H, which is 762.5. So 762.5 by the cos of 26.33 degrees is equal to 683.4. So what's that telling me? 683.4, oh, that's not my diagram gone, is this distance in here, from here to here. So how long does it take to travel along that section? We have how long it took to travel from back here to O, 28.125. So we need the magnitude of the velocity of A relative to B. The magnitude of the velocity of A relative to B, the square root of 28 squared plus 8 root 3 to be squared, which is 192. So I'll just put in 8 root 3 to be squared, just to be sure. 8 root 3 to be squared, and that's coming out to be 31.24. And if I divide my 683 by 31.24, what do I get? 21.875 exactly. And I need to say 28.125 minus this guy is the time interval along that section after the shortest distance, which is 6.25 seconds, which was one of the options back on one of those earlier slides. Can we find it? Disappeared. Let's try and continue with this and put another slide on. Let's see, can we get it working? So I can't tell if that recorded. Let's go over it again. A is 450 away and getting a 16 closer every second. B is 200 away and is getting further away, sorry, 200 away and getting 20 further away every second. And if we solve these down, T is 250 over 36, 6.94. Question 6 and 7 are this river question. Here's my river bank. It is 510 wide. Usually the intro to these questions are the quickest way across, quickest route. Well, in the J direction, this guy can go 1.7 in the J direction. So 510, 1.7 in still water. 510 over 1.7 is 300 seconds. Easy enough start for question 6. Question 7 is the shortest route, which is straight across. So we want to find out what relative speed the boat can go in this direction. So it's going to set out in this direction at an angle, let's call it A, to the horizontal. And if we have this triangle, and we have, in terms of t, the distance traveled, we have the river flowing at 0.8 t, the man is traveling at 1.7 t, so the man's speed directly across is just Pythagoras, the square root of 1.7 squared minus 0.8 squared, and that's our 17, 15, 8 triangle, and that's 1.5, so that's his relative speed. It's 510 wide. If we divide it by 1.5, the slower speed to get straight across, we get 340, which was this one. Last question was a Ryanair drone flying at maximum speed. It's traveling due west at 100 kilometers an hour. So the velocity of the drone is equal to due west, so 0i minus 100 in the J direction. That's the velocity of the drone. It's partly helped by a wind, and we're given the wind here. The wind's velocity is 20 in a direction 30 degrees north of west, 30 degrees north of west is that direction, which is negative positive. So the velocity of the wind here is going to be equal to negative positive, so negative 20 cos 30 in the I direction, positive 20 sine 30 in the J direction. Cos of 30 is root 3 over 2, so minus 10 root 3 in the I direction, plus sine of 30 is a half 10 in the J direction. The velocity of my wind. We're at the maximum speed of the drone in still air, similar to kind of the guy crossing the river. What's the speed of the actual speed of this Ryanair drone? So we need the velocity of the drone relative to the wind, which is equal to the velocity of the drone minus the velocity of the wind, which is equal to 0 minus 10 root 3. Just in a row here in the J direction, it's going due west, so it's 0 in the J direction and 100 in the I direction. My bad. Sure you've noticed that. So D minus W is 100 minus 10 root 3. Now I'll do that in a calculator. So it's minus, it's due west, minus 100, minus 100. So minus 100 plus this 10 root 3 is going to give me 82.68, minus 82.68 in the I direction. And then in the J direction we have the 0 minus 10. It's going to be minus 10 in the J direction. That's the velocity of the drone relative to wind. So the magnitude of this will give us its speed, which is going to give the square root of 82.68 squared plus 10 squared, which they all look very similar. Just be careful looking at the numbers. 83.28 kilometers an hour for this one, which was here. So that's the solution to your test. Suppose 17 minutes to do the solution is probably a 30-minute test, taking your time and drawing good diagrams.